Okay, hello, pre-calc people. So let's just quickly review what we did on Friday. We just talked about circles. So if it's in this form, this should not be a very big challenge for us. We know the center and we know the radius. The center here is 3, -1, and the radius is 7. Because remember, when it's in this form, I think graphing form is a good phrase for it because we can easily graph it. We know the center of the circle, and this is the radius squared. So the radius has to be 7. Here, the center is -6, 5, and their radius would be 9. Don't forget these squares up here. Lots of students do. Now, if you don't have it in that form, that's going to be your biggest challenge. Your biggest algebraic challenge is to put it in that form. So if you're given this form, how do you put it into graphing form? You have to complete the square, which means you have to find these red numbers, 9 and 4. And where do they come from? Well, 9 is half of -6 squared. Half of -6 is -3, and -3 squared is 9. Half of 4 squared, I'm sorry, half of 4 is 2, and 2 squared is 4. So we added 9, we added 4. We do it to the right side to keep the balance. Now on the right side, 12 plus 9 plus 4 is 25. On the left side, this is the whole point. The whole point of completing the square is that you can factor it, and it will be a binomial squared. This factors into x minus 3 squared. This factors into y plus 2 squared. So now we know the center and the radius of this circle. The center is 3, -2. The radius is 5. So this is in your notes. Please pause the video when I'm going too fast for you to write it down and then catch up. So this is the equation. It is a circle. And the first thing we want to do is reorganize all 5 of these terms. I'm going to get the number 32 on the right-hand side, and I'm going to get all the x's and the y's on the left-hand side. And I'm going to organize them by term. So x goes with x, y goes with y, etc. So here's the movement that happened. I subtracted 10x on both sides. I subtracted 8y on both sides. I subtracted 32 on both sides. And then now is the hard part. And if you don't think it's hard, that's great. You have to complete the square. So what goes here? Remember on that last example, 9 was the number you need to find. That's half of -6 squared. So same idea, half of -10 is -5. And if I square -5, I get positive 25. Do it to both sides to keep the balance. And then the second square, half of -8 is -4. If you square -4, you get 16. So plus 16 on both sides. What is the point of doing all that? Well, first of all, these 3 numbers, -32 plus 25 plus 16, they all add up to 9. But the big point is that you have completed the square. You have created a trinomial that factors into something squared. This trinomial factors into x minus 5 squared. This trinomial factors into y minus 4 squared. And so now we know the center and the radius. The center is 5, 4, and the radius is 3. Another example, maybe pause the video and try to do this one on your own. But this is a similar example. So I reorganize everything. I get all the x's together and I leave some space. I get all the y's together and I leave some space. And I want to complete the square. So what goes here? Half of 12 is 6. 6 squared is 36. I do it on both sides, got to keep the balance. Half of -2 is -1. I square that, I get positive 1. Do it on both sides, keep the balance. 27 plus 36 plus 1 is 64. This trinomial factors into x plus 6 squared. This trinomial factors into y minus 1 squared. And now I know the center and the radius. The center is -6, 1. The radius is 8. We were asked to graph it. So I would go from the origin to the left 6, up 1, and then graph, and then try to go 8 in all directions as best as I can. And then moving on to a warped circle, which is an ellipse. So I guess this is an ellipse here. This is in Brussels. And ellipse, ellipse, ellipse. This is someone's cat furniture with every shelf is an ellipse. Okay, there's even an ellipse right here in this picture. And an ellipse, well, an ellipse is kind of like a squashed circle, but there are some things that you're going to be responsible for sure the center. And you notice that there's kind of like a long spine to this ellipse and a shorter spine. So this long one is called the major axis. And the the endpoints of the major axis, they're both A away from the center. This is called the minor axis. So they are B away from the center. And you'll find out what A and B are in just a minute. But then the key thing about an ellipse are the foci. So you've got a focus on one side and a focus on the other side. And I kind of talked about that a little bit in class where, remember that guy who made the pool table out of an ellipse? And he shot the ball at one focus, and no matter where he shot it, it always ended up at the other focus. But we're just kind of dipping our toes into this. This is the last page, and then we'll talk more about it tomorrow, Tuesday. So an ellipse, this definition is not going to be satisfying to you at all, but it's basically, it's an oval shape, but all the x, y's, all the points on the ellipse, if you just pick a random point and take the distance from that point to one focus and then add it to the distance to the other focus, you would get a number, right? This distance plus this distance. Well, that sum, when you add them up, is equal to all other possible sums. Like if you pick any other point on the ellipse, you measure this distance, you measure the other distance, you add them up, it'll be the same sum as this sum over here. This distance plus this distance. It'll be the same sum as this one, this distance plus this distance. Yeah. The major axis is oh Lord. The major axis is this orange one. So it could be orientated vertically or horizontally. So vertical or horizontal. The green one is the minor axis. So the major axis, you could think of it as like the long length of the ellipse, and the minor axis is the short length. And remember, the major axis is A away from the center, and the minor is B away from the center. The foci are C away from the center. You can have ellipses can be orientated vertically or horizontally. The center is the center, the little red dot, the center of the ellipse. The foci are those purple dots, and they are C away from the center. And I would imagine you're gonna have this on your test, these formulas, since this is way more to remember than the sequence test, and you were given the formulas for the sequences. So here's the graphing form of an ellipse. Like some people call it the standard form, but it's more meaningful to think of it as the graphing form, because if you have this form, you can graph it pretty darn easily. And this one's horizontal and this one's vertical. What in the world is the difference between these two? Can you spot it? The only difference is the A and the B. A is always bigger. A is always bigger. So since A is underneath the X value, it's stretching left and right more because A is bigger. B is underneath the Y, so it's going to stretch up and down a B amount. A is underneath X, so it's going to stretch left and right an A amount. And since A is bigger, that would be a horizontal. Here, when A is underneath the Y value, then it's the bigger stretch is going up and down because Y is in charge of going up and down. So this is how you can tell if the ellipse is orientated left and right or up and down, wherever the A is, wherever the bigger number is. The center, just like a circle, is HK. The major axis, how long is the major axis? Remember, guys, the major axis is this orange one. So the major axis is A away, the endpoint is A away from the center. So you have to go A in this direction and A in that direction. Well, how long does that make this big orange thing? If you go A in one direction and A in the other direction, don't we see that this whole length has got to be 2A's? And you are right. If you thought that, the length of the major axis is 2A, twice A. The minor axis, you go to the left and to the right, a B value. So the length of the minor axis is 2B. Whether you're facing up and down or left and right, the minor axis is always, you get B away from the center to span the minor axis. So 2B. The foci, which is plural for focus, you got two foci. They are C away from the center. The foci are C away from the center. So if your ellipse is facing left and right, then your C value has to go to the left. I'm sorry, your foci, you go to the left C and you go to the right C. So notice here's the center, HK. You see how you're adding C to H and you're subtracting C from H? That's affecting the X value. So your X value from the center is moving left and right. This one over here is a vertical ellipse because the C is affecting the Y value. K is the Y value of the center. So if you add C to the Y value, you're going up. If you subtract C from the Y value, you're going down. So if you have a horizontal ellipse, this is how you find your foci. If you have a vertical ellipse, this is how you find it. And C is, I can only imagine what you're thinking right now. C is the square root of A squared minus B squared. You're going to have this information, so don't worry. And we will practice doing this tomorrow in class. You just find it, you can usually find it all in one shot. I'll give you an equation like this, and I'll ask for everything. You know, what's the center, HK? How long is the major axis? Well, it's twice A. So if you've got 25 under here, then A is 5, and the major axis is 10 long. And if B squared is 16, that means B is 4, because remember, the number under here is B squared. So if this is 16, B is 4. And the length of the minor axis would be twice that. So it would be 8, 2 times 4. You guys will be great with this. We just have to put in some work to get used to using all of these formulas. Good luck. I'll see you tomorrow. Please work on your homework sheet for the rest of the period.